Just go over the origins of the dot plot and then its relation to the bootstrap. So this is the ballware, which was the first data set, so it's the expenditure, boys versus girls, males versus females. We would graph it originally there, and we would see there's an original difference in the median spending, boys at 200 and 310. So there's a difference of $110 in the medians of those samples. If I bootstrap, the dilemma I get here is that it happens very quickly. And I get this. Now, the top here is just the same graph squashed up. We lose room for the summary. So we've still got the difference of 310 compared to 200. So the difference of 110. And that 110 you'll see here. What all of these dots here are a result of bootstrapping. So resampling from the original sample, finding a median for the female spending, resampling from the original sample for the males, finding a median, and then going female minus male and getting another difference. 110 was our original one. The problem with this is it looks really quick. So we're going to look at a simplified version that we did in class. So in class we took a smaller sample, so we just had 10 and we picked them out. In yellow I've got female and in green I've got male. This is the same data. And with the resampling, the thing to take notice of is when we select one of these, it can come in again. And an example of that would be the 840 here. You'll see that the 840 comes up twice in that woman's sample of spending, but so conversely some of the numbers in the sample, like the 300, doesn't come up anywhere in that first sample. This cell at the end is simply the median of that sample there, and it's done with resampling, so there's some repeats and some exclusions. At the same time, corresponding to that is the boys' first sample. Now again, that's in green, so it's from here. So anything from those 10 can be chosen, but if it's chosen once, like the 80, it can be chosen again. Now we've got 80 twice in our original sample, so we can't tell which is which, but we've got 80 here, 80 here, 80 comes up 3 times. The 0's 1 time in the sample and it's there. We've got a couple of 190s, we've got 3 190s, but in our original sample there was only 1. So we're basically picking one randomly out of a hat, but before we make the next pick, that one we picked out is dropped back in, so there's potential for it to be picked more than once. What a bootstrap looks like is, so we take our sample from the females, find the median, which is the whole point of the sample, or the resample more correctly. At the same time, or immediately after, I take a resample for the males, the guys spending, and I get their median. What this cell here does is it takes the female median, because the original females had a higher median spending, and it subtracts the male median of. So this 135 is not a curious number, it's a logical number. 280, the median for the females based on the resample, minus 145, the median for the males based on the resample. The difference is that. When I redo the second one, and we did this in class and picked them out of the hat, when I redo them, the next time I did the female sample, got a few repeats, got a couple of the 840s, got the 1000 mentioned here, got a few missed out. But anyway, we got a slightly higher median this time. And so this time the median was 350 for the females. When I did the resample for the males, although it's a slightly different resample and a whole lot of 190s, comes up 4 times. The 0 guy came up twice, but actually generated the same median. The important thing about this, though, is the difference between the two medians, which is what we measure, 350 minus 145, that actually gives us a difference of $205. So those two are actually the important figures that are recorded. So if I go back to NZ Grapher, so this is a record of what we did in the class for bootstrapping twice. 135 and 205 are the differences. Female median minus male median. If I go back here, you can see 205 would be about here, and 135 would be in here. And all of these dots stacked up are the result of that process. The problem with NZ Grapher is it does it 1,000 times. So those are individual differences from when you've resampled a sample of the females, found the median, a resample of the males, found the median. In both of those resamples, we've got plenty of repeats and different ones missed out different times. But when we do the subtraction, that's the value we care about, and 95% of them land somewhere between $90 more for the females and $200 more for the females. And so when you look at that graph, go back, keep that process that we used in mind that generated it, and remember that all of those dots, that collection of dots, and that 95% confidence interval, which is the bulk of them with the ones on the fringes cut off, like these ones here and these ones here, that represents 1,000 times through that cycle.